Okay, let's unpack this fundamental question, one that's really been around for centuries. What is it about our inner subjective experience? That feel of consciousness. Why does it seem so hard to explain just in physical terms?
Right. It's what David Chalmers famously called the hard problem of consciousness. He really nailed that gap between, as he put it, the whir of information processing in our brains.
All the objective stuff, the neurons firing.
Exactly. Between that and the actual subjective experience, the rich inner life, he asked, why should physical processing give rise to a rich inner life at all? It seems objectively unreasonable that it should, and yet it does. It's a fantastic puzzle.
It really is. And it forces us to look at our assumptions, doesn't it?
It absolutely does. The usual scientific approach often sees consciousness as emerging from brain activity, like a byproduct of complexity.
An epiphenomenon, sort of.
Precisely. But Chalmers and quite a few others started questioning that. He even suggested later that maybe consciousness isn't emergent at all. Maybe it's fundamental.
Fundamental, like space or time.
Yeah. Exactly like that. Not something built from simpler parts, but a basic constituent of reality itself. And that, well, that just opens up a whole new landscape of possibilities way beyond the standard materialist view.
So the key insight for you, the listener, is that maybe the very bedrock of reality is more complex than we usually think.
That's the crux of it. It really challenges our standard picture.
Okay, and it's that challenge, that push beyond the conventional, that brings us to today's deep dive.
Yeah.
We're going to explore a really fascinating, maybe even radical perspective, the Pribram Bohm Holoflux theory. This isn't your typical neuroscience focusing only on the brain. It's more of a topological approach, drawing on some really deep ideas.
It is. It's a synthesis, really, of two major streams of thought. You've got Karl Pribram, the neuroscientist, and his work on holonomic mind-brain theories.
Right, trying to figure out how the brain actually processes information.
Yes. And then you have David Bohm, the theoretical physicist, and his very unique ontological interpretation of quantum theory.
Two very different fields, physics and neuroscience.
Indeed. But both Pribram and Bohm, coming from these different directions, ended up suggesting that reality is much more interconnected, much less localized than our everyday senses tell us. Imagine these two brilliant minds wrestling with these huge questions.
So what's the core concept that comes out of bringing their ideas together? What's the gist?
The central idea is something they called the holoflux. Pribram actually coined that term for what Bohm had earlier called the holo movement.
Holoflux.
Think of it as a fundamental, ongoing, two-way flow of consciousness. An energy, really, that's constantly moving, transforming between two different orders of reality.
Two orders.
Yes. There's the explicate order. That's the familiar world of space and time we perceive, with separate objects and events.
The world we see and touch.
Right. And then there's the implicate order, a deeper and folded reality that's beyond our direct senses. More fundamental.
Unfolded, like hidden or underlying.
Kind of. It's the source from which the explicate order unfolds. So the holoflux is this constant movement, this dynamic between the unfolded implicate and the unfolded explicate.
So the takeaway for you listening is that things we see as separate might actually be deeply connected at this implicate level, like ripples on one big pond.
That's a great way to put it. The theory suggests a fundamental entanglement beyond immediate appearances.
Okay, so if I'm tracking this, consciousness isn't just locked inside our skulls, not just electrical chatter between neurons.
That's a really critical point the theory makes. It suggests consciousness is more fundamental, a dynamic flow of energy that doesn't inherently have spatial or temporal limits. It exists as a spectrum in that implicate order.
A frequency domain, perhaps?
Pribram would definitely link it to a frequency domain, yes.
Yeah.
And this energy then resonates with electromagnetic energy in our space-time, the explicate order. It's a continuous translation back and forth.
Wow. That sounds like it could potentially explain some pretty weird stuff, right? Not just everyday perception, but maybe non-local things, stuff that doesn't fit neatly into space and time.
That's certainly one of the implications. It offers a potential way to think about how experiences or events that seem separate could be connected at a deeper level. And crucially, for that hard problem we started with.
Right, bridging the gap.
Exactly. It tries to bridge that gap between subjective experience and the physical world by saying they aren't ultimately separate, but different aspects of this underlying holoflux.
Okay, this is fascinating. Before we dive deeper into Pribram and Bohm individually, can you give us a quick roadmap? What are the main stops on this journey today?
Sure. We'll definitely circle back to Chalmers' hard problem and look closely at the assumptions, the Holoflux theory challenges. Then we'll touch on some early, maybe unconventional explorations of consciousness, like John Lilly's work.
The dolphin communication and isolation tanks.
That's him. Then we'll really get into Karl Pribram's work, The Brain as a Frequency Processor, and David Bohm's concept of the implicate order, which is profound.
And how they connect.
Yes. Crucially, how the Fourier transform provides a mathematical bridge between their ideas. And finally, we'll see how this Pribram-Bohm view aligns or resonates with other perspectives, like Erwin László's holofield theory and Rupert Sheldrake's morphic resonance.
Okay, great. Lot to cover. Let's dig back into that hard problem then. You mentioned Chalmers suggesting consciousness might be fundamental, like space. How does thinking about it that way really change things?
It's a massive shift. I mean, if consciousness is fundamental, we stop trying to explain how it arises from non-conscious stuff, which is where the hard problem bites, right?
Right. How do you get experience from just matter and energy?
Exactly. But if it's fundamental, like charge or mass, it just is. We don't need to derive it. It bypasses that seemingly impossible leap. It suggests consciousness was maybe always part of the universe's fabric, not just a late arrival from complex biology.
So if it's not just human brains in space-time, what specific assumptions in consciousness research does that really shake up?
Well, several big ones. First, the idea that consciousness automatically means human consciousness. If it's fundamental, maybe it exists in broader context, perhaps even beyond biology, down at fundamental physical levels.
Okay.
Second, it questions if consciousness is strictly confined to space-time as we perceive it. If there's this implicate order beyond our senses, maybe consciousness in its basic form operates there too, unbound by our local space and time.
Like experiences of timelessness or spacelessness people sometimes report?
Potentially, yes. And third, it challenges the idea that consciousness is purely localized in the brain. It points towards something more distributed, more interconnected.
That is a radical departure. It makes you think differently about, well, things like mystical experiences or near-death accounts where people describe feeling outside of normal space and time.
It does. While mainstream science often struggles with how to handle those subjective reports, this theory at least offers a conceptual framework, a kind of topology, where such experiences might make sense. Not validating every claim, of course, but providing a way to consider phenomena that don't fit the standard materialist box.
It's interesting how these ideas connect back to early explorers, the psychonauts mentioned in the paper, like John Lilly. He really pushed boundaries.
Lilly is definitely a complex figure, but his background was unique: physics, math, electronics, giving him a different lens. He tried to bring some rigor to his, let's say, unconventional explorations.
I remember reading about his work with dolphins, trying to communicate. That was pretty out there for its time.
It was. He believed communication could happen beyond just visual or vocal means. He recorded audio, even electromagnetic interactions between humans and dolphins. And significantly, he used Fourier analysis on those recordings.
Fourier analysis, even back then.
Yes, trying to find frequency patterns that might correlate with information exchange. An early attempt to find objective markers for something inherently subjective like communication.
And then his work shifted, quite dramatically, to isolation tanks and substances like LSD and ketamine.
It was a controversial shift, for sure, but he was relentlessly curious about consciousness itself. The tanks minimized external input, letting the internal landscape emerge. The substances were tools, in his view, to probe the boundaries of normal consciousness.
There's that striking quote in the paper from his ketamine logs in the tank. Everything was happening on such a vast scale that I was merely an observer of microscopic size. And yet I was more than this. I was part of some vast network. It speaks to that deep interconnectedness.
It really does. And while these experiences are hard to pin down scientifically, they resonate strongly with the core ideas of interconnectedness and an underlying order in the Pribram-Bohm theory. Plus, Lilly's later idea of consciousness having programmable software layers also hints at a complex, maybe non-local architecture.
So how does the Pribram-Bohm model, shown in Figure 3, actually visualize this flow, this transformation between the non-local implicate and the local explicate orders?
Right. Figure 3 gives us a schematic. On the left, you have consciousness depicted as this spectrum of holoflux energy, located in the non-local implicate order. It's not in space-time there.
Yep.
Then, as you move right across the diagram, that holoflux energy is shown resonating with electromagnetic energy of the same frequencies within our space-time region, the explicate order. So the connection is frequency resonance.
And the arrows showed it's a two-way street, right? A constant exchange.
Exactly. Arrows left to right show the implicate unfolding into the explic, becoming the objects and events we perceive. Arrows right to left show information from space-time interactions folding back into the implicate order. It's a continuous dynamic cycle.
That brings us neatly to superposition and the role of the Fourier transform. This sounds like the mathematical engine driving this.
It's absolutely key. Think about our conscious experience right now. Sights, sounds, thoughts, feelings, all happening at once, yet integrated into a single unified moment. That ability to hold multiple streams simultaneously is what's meant here by superposition in consciousness.
And Fourier helps explain how that integration happens.
Well, Fourier analysis, developed by Jean-Baptiste Fourier back in the 19th century, gives us the mathematical tool. He figured out how to break down complex signals in space-time into their basic underlying frequencies.
Like taking a musical chord apart into individual notes.
That's a perfect analogy. The Fourier transform lets you decompose the chord of space-time experience into the notes of the frequency domain. And importantly, it lets you reconstruct the chord from the notes. It's a bridge between these two ways of describing things.
So it allows analysis and synthesis between space-time and frequency.
Precisely. And it's incredibly powerful, used everywhere in science and engineering.
And Norbert Wiener, the cybernetics pioneer, used it to study brainwaves.
He did. Wiener applied Fourier analysis extensively to EEGs. He noticed brainwave frequencies seemed to resonate, to kind of self-tune in certain cortical areas. He even speculated, interestingly, that the infrared band might be crucial for this self-organization in the brain.
It's fascinating that David Bohm, coming from fundamental quantum physics, also stressed the importance of Fourier analysis.
It's very significant. Right on page 1 of his major book, Quantum Theory, Bohm says Fourier analysis is practically indispensable for understanding quantum mechanics. It wasn't just a handy tool for him, it was fundamental to understanding reality at that level.
So the Pribram-Bohm model isn't just using Fourier as a nice analogy.
No, not at all. It goes much further. It proposes that the frequency domain has an ontological reality. It's not just a mathematical space we use for analysis, it's a real aspect of existence. They equate it with Bohm's implicate order, Pribram's holonomic frequency domain, even László's Akashic holofield.
So reality isn't just space and time. There's this whole other equally real frequency dimension.
That's the radical idea. It really echoes what William James said about potentially plunging into an altogether other dimension of existence from the sensible. He called it the mystical region.
It seems like these scientists, with math and physics, were arriving at something conceptually similar, just via a different route.
It certainly looks that way, a convergence towards realms beyond our everyday senses. And the Fourier transform, in this view, isn't just math, it's reflecting a fundamental structure of the cosmos.
Okay, let's focus now on Karl Pribram's holonomic theory. What was he initially trying to solve? What were his main research questions?
Pribram was really chasing two big questions for decades. First, where is memory stored? The search for the enneagram, the physical trace of a memory.
Right, the holy grail of memory research for a long time.
Exactly. And second, how does visual perception work? How does the brain create our visual world from the signals coming from the eyes?
And what did his experiments lead him to conclude?
His work piled up evidence suggesting the brain performs something very much like Fourier transformations on visual signals. And critically, he found the patterns representing this information weren't in one specific spot.
Not localized.
No, they were distributed across wide networks of dendrites, those intricate branching structures of neurons. This distributed nature was a key finding that pushed him towards a different kind of model.
And that's where holograms came in as an inspiration.
Precisely. Optical holograms emerged in the 60s, and Pribram was struck by how they stored information. The entire image is encoded everywhere on the holographic plate in the interference patterns of light waves.
Distributed storage.
Yes, he saw a powerful analogy. Maybe the brain stored memories and processed perception holographically. So in 1971, he proposed the holonomic brain theory. Memory, sight, hearing, maybe consciousness itself, operate via Fourier transforms between space-time patterns and this underlying frequency domain in the brain.
So he was directly challenging the idea of specific memory spots, like files on a hard drive.
Absolutely. No localized engrams in this view. Memory is encoded in the wave interference patterns across neural networks. And importantly, it also challenged the idea that consciousness is just a passive byproduct. Pribram saw it as integral to this transformation process.
There's that anecdote about him hiking in the Rockies.
Ah, yes, that's revealing. He was hiking just before a big conference, and Fergus Campbell, another vision researcher, asked him point blank, "Do you really think the brain is doing Fourier transforms?"
And Pribram hesitated.
Initially, yeah. He apparently downplayed it, maybe worried it sounded too radical, but then he thought more about his data, the explanatory power, and decided, yes, I'm going to present this. It shows how unconventional the idea was then.
And he saw holography as this physical proof of concept for information coded in frequency patterns.
Yes, exactly. Holograms store 3D info as wave interference patterns superimpose frequencies. He thought the brain did something similar, operating in a frequency domain linked to the neural tissue via flux fields in the dendritic networks. It's about dynamic wave patterns, not static storage bins.
And figure 5, that diagram by Jeffrey Chu, was important for Pribram.
Hugely important. Chu, a respected physicist, presented this diagram showing the spectral domain, frequencies, and the space-time domain bridged by the Fourier transform. Crucially, it situated this relationship at the quantum level, involving Planck's constant.
Planck's constant, the fundamental unit of quantum action.
Right. And Pribram heard this diagram had roots going back to Paul Dirac, a giant of quantum mechanics. That gave it immense weight. He included it in his book Consciousness Reassessed, captioning it to highlight the Fourier transform linking these two domains.
So that diagram really cemented for him how frequency and space-time might be fundamentally linked at the quantum level.
It seems so. It gave him a visual and theoretical anchor for this dynamic interplay he was proposing, happening right at the edge of classical reality, at the Planck scale boundary, almost like an event horizon between these realms.
Which leads us perfectly into the limits of space and Planck's constant. How does the Pribram-Bohm idea view space at the tiniest scales?
Well, it proposes space isn't infinitely smooth and divisible. It suggests space has finite dimensions, a smallest possible unit. This actually aligns quite well with things like string theory or M theory and modern physics.
Where extra dimensions are curled up really small.
Exactly. Those theories talk about extra dimensions being compactified down at the Planck scale around 1035 meters. Incredibly tiny.
So the Planck length is like the ultimate pixel size of space.
That's the idea. It's the scale where quantum gravity effects dominate and our normal smooth picture of spacetime breaks down. Figure 7 in the paper shows this visually. Planck length is at the very bottom, the boundary between the explicate order we see and the deeper implicate order.
And does space actually end there in this model?
In a sense, yes. As you conceptually zoom down to the Planck length, space as we know it dissolves. That's the point where the theory says you enter Bohm's implicate order or Pribram's frequency domain. It's a fundamental discontinuity.
It makes me think of John Wheeler's idea of quantum foam at that scale.
Right. Bohm himself mentioned Wheeler's quantum foam concept. Instead of smooth continuity between points at that scale, it's this probabilistic, fluctuating foam-like structure, a very different picture from classical space.
Okay, let's talk about the meeting between Pribram and Bohm. How did their ideas start to merge?
Their meeting in Cordoba in 1979 was apparently quite electric. Pribram immediately saw how Bohm's implicate order model was a perfect fit conceptually for his own holonomic brain theory.
A framework for his frequency domain idea.
Exactly. And that kicked off about 20 years of dialogue and friendship between them. There's that photo, figure 8 of them together in Prague.
What were the key points of connection they found?
Pribram saw Bohm's implicate order as the place where his frequency domain flux could reside. The Fourier transform was the mechanism for unfolding that implicate information into explicate waves the brain could process. And he liked Bohm's idea of information folding back into the implicate order.
A complete cycle. And Bohm saw connections to consciousness, too.
Oh, absolutely. Bohm strongly believed quantum theory and consciousness shared the implicate order as their common ground. He saw quantum non-locality, that weird instantaneous connection between particles, as a natural feature of this enfolded order.
Like, things are fundamentally connected there, even if they look separate here.
Precisely. Bohm even thought this enfolding-gunfolding process might explain things like Sheldrake's morphic resonance, how past patterns could influence present forms without a clear energy link in space-time.
Because the connection happens in the implicate order. outside of normal space and time.
That was the idea. Bohm described the implicate order as a ground beyond time. Each moment is projected out, then interjected or folded back in. This cycle could allow past forms to reappear or resonate because in the implicate order, similar things are essentially connected regardless of when or where they occurred in the explicate order.
And Pribram specifically tied this to his idea of information at the Planck boundary.
Yes, he saw the Planck length as the crucial interface. Spectral density, this energy flux in the frequency domain, undergoes exformation there, becoming matter and energy in spacetime. And mind thought arises from internalized information of that spectral density. For him, the spectral density was just as real as spacetime, just existing beyond it.
So again, Fourier wasn't just math for him. It reflected a deep reality.
Definitely. He made that conceptual leap. The Fourier relationship wasn't just descriptive. It implied an actual ontologically real domain beyond space-time where energy exists as flux measured as spectral density. Figure 9 tries to capture this visually, almost like consciousness peering out from the implicate into space-time through the Fourier lens.
Which brings us to that G. Spencer Brown quote about the world needing to divide itself into seer and seen to observe itself. Very philosophical.
It is. It touches on that self-referential loop. To perceive, you need a distinction between observer and observed. It resonates with the idea of consciousness projecting itself out, explicate, and then observing its own manifestation through perception.
Let's broaden out to cosmology. Bohm's 1980 book, Wholeness and the Implicate Order, tackled the big picture implications.
It really did. He applied the implicate order concept to the whole cosmos. He even tackled the zero-point energy problem, the potentially infinite energy of empty space in quantum field theory.
How?
By suggesting the Planck length imposes a shortest possible wavelength, which naturally makes the total vacuum energy finite, not infinite.
He also connected it to older ideas, like the ether or plenum.
Yes, he referenced the old Greek idea of a space-filling plenum and the 19th century ether. He then proposed his holomovement happening within this vast sea of zero-point energy, a multidimensional implicate order. He said empty space isn't empty, it is the plenum, the ground state. Observable things are just forms arising from it.
So for Bohm, consciousness wasn't just in the plenum, it was fundamental to it.
Absolutely. He concluded that consciousness should be understood in terms of the implicate order as its primary and immediate actuality. Consciousness is right there at the foundation of reality, in his view.
Which leads to this idea of space-time being projected from a holoplenum. It sounds a bit like the holographic universe idea.
It's definitely related. The model suggests a kind of transcendent consciousness within this plenum, may be pictured as a matrix of quantum black holes at the Planck length, projecting our spatial cosmos holographically. Each point at the base level is a potential projection source.
Like pixels combining to make an image?
Something like that, yes. The holoplenum projects the 3D cosmos outward. But crucially, it's not just one way. There's a constant inward flow to information, maybe gravity going back into the implicate order at the center of every point, a dynamic feedback loop.
And the Ouroboros symbol, the snake eating its tail, represents this cycle.
Exactly. It's an ancient symbol of this kind of cybernetic feedback, output influencing input, found in alchemy, Egypt. It captures that self-referential loop of projection and interjection, like audio feedback, in a cosmic sense.
The paper also calls the boundary between implicate and explicate a turbulent event horizon.
Yes, it's seen as this dynamic interface. Information flowing inward from our space-time loses its local entropic nature there, becoming non-local and superposition within the holoplenum's network of quantum black holes. And that holoplenum acts as the 3D projection field for our reality.
So it's not just space that's granular, but time, too, with Planck time.
That's right. Just like Planck length for space, there's Planck time about 1044 seconds. John Wheeler pointed out this sets the ultimate speed limit for any process, the fastest possible tick of any clock in the universe. Below that, time itself might not have meaning.
An unbelievably fast clock rate.
Mind-bogglingly fast. Wheeler talked about quantum fluctuations, virtual particles popping in and out of existence happening at this Planck timescale. The maximum theoretical clock speed of the universe would be the inverse of Planck time, around 1044 hertz.
Oh, and this granularity connects to Dewey's theory of laminated spacetime.
Yes, Dewey's 1985 theory fits well. It sees flux extruding into space-time in discrete quantum shells or laminae, moving at light speed, with each shell separated by one Planck length. So a layered, granular structure. Dewey described the universe as composed of these shells of electromagnetic particles.
How do familiar laser holograms compare to this cosmic holoplenum idea?
Laser holograms are a helpful analogy, but vastly simpler. They use one coherent light source, fixed points, recording interference on a 2D plate.
Whereas the universe's flux is much more complex.
Immensely more complex. Think of a 3D matrix of intersecting energy shells of all frequencies coming from all directions. Every single point in space-time intercepts this entire frequency spectrum flowing into the quantum black hole at its center, according to the model.
So the universe's hologram isn't static, it's this ongoing dynamic resonance.
Precisely. It's Bohm's continuous projection and introjection, the resonance between the implicate and explicate orders, mediated by processes like the Fourier transform, that gives rise to the dynamic, evolving holonomic universe we experience.
Okay, this connects us to Erwin László and his holofield theory. How does his work fit in?
László's theory lines up remarkably well. He talks about an A dimension, which he equates with the implicate order or frequency domain, and an M dimension, the explicate material space-time domain.
And László also emphasizes a unified field of consciousness, coming from philosophy and systems theory.
Yes, he argues for a fundamental non-local coherence in the universe, seeing everything as part of one unified consciousness field. Like Wheeler, focusing on information, László talks about an underlying information field, or A field, often calling it the Akashic field.
Akasha. That's an ancient term, isn't it?
It is, from Vedic texts. It refers to a primordial substance or ether, often linked to vibration or sound, the basis of everything. Some interpretations see it as a field of potential energy rooted in consciousness. László picks up this term for his fundamental A field.
So in his view, the universe is the interaction between this Akashic field, A dimension, and the material world, M dimension.
Exactly. The A dimension acts like the universe's memory, an Akashic record outside space-time. There's a constant two-way flow. The A dimension holds the blueprint, influencing the M dimension, and information from the M dimension flows back, updating the A dimension.
Could this provide a structure for Sheldrake's morphic resonance?
It's certainly compatible. Both László's and Pribram Bohm's models offer potential architectures for how morphic fields, which seem to carry memory across time and space, might work. Sheldrake himself suggested morphic fields might interact with quantum fields, maybe the vacuum field.
And László takes it a step further.
He suggests morphic resonance is the result of species interacting with the A dimension over long periods. The A dimension encodes the norms for a species, acting as an attractor, an information blueprint influencing development and behavior.
But a key challenge is that László hasn't connected this A field to known physics, right?
That's the sticking point, scientifically. He insists it must be rooted in science, but he hasn't identified the Akashic field with any known physical field. It remains, as he acknowledges, unknown to current physics, which makes it hard for mainstream science to embrace.
Still, the blueprint idea is interesting, especially regarding the universe's fine-tuned constants.
It is. If you speculate, like cosmologist Lee Smolin does about physical laws evolving, that maybe the A field contains information from previous universes, it could offer a way to think about why our constants seem so perfectly set up for life and consciousness. It's highly speculative, but interesting.
But using terms like Akasha, Akashic record, spiritual, doesn't that create resistance in science?
It often does, unfortunately. Those terms come loaded with historical baggage from theosophy, Steiner, case claims of accessing cosmic memory via trance or special perception. Even though László tries to ground it scientifically, the language itself can be a barrier for many scientists who prioritize empirical, measurable data.
Though his ideas do seem to resonate with more experiential data outside of strict materialism.
That's true. His discussions of altered states, holographic information, and consciousness, they align with Pribram and Bohm in suggesting we might need to look beyond reductionism. He sees space and time as connecting things, not just separating them, within this larger Akashic framework, a fifth dimension perhaps, underpinning everything. It points towards a paradigm shift where information is seen as the fundamental reality.
So, wrapping up, how do these theories, Pribram, Bohm, László, offer perspectives on the hard problem we started with?
Well, as Figure 12 suggests, the Pribram-Bohm topology can be seen as correlating with several approaches to consciousness: Chalmers, Lilly, Bloch, Even Teilhard de Chardin, it doesn't give a final scientific proof solution in the normal sense.
But it offers an alternative framework.
Exactly, an alternative to purely materialistic explanations. It provides a way to think about consciousness not as something emerging late and locally, but as a fundamental, intrinsic aspect of the universe, woven into its very fabric, operating through processes like the holoflux between implicate and explicate orders.
Okay, so to quickly recap our deep dive, the Pribram-Bohm Holoflux theory paints a picture of this constant dance between a deeper, enfolded implicate order and our perceived explicate order. The Fourier transform is key to this exchange, and consciousness isn't just brain stuff, but something more fundamental, a flow of energy and information.
That's the essence of it. A universe where consciousness and information are truly fundamental. It's an ambitious framework, yes, but one that potentially offers new ways to understand perception, non-locality, interconnectedness, and maybe, just maybe, a way to bridge that stubborn gap between subjective experience and the objective world.
All right, here's a final thought for you to take away and chew on. If our reality is fundamentally a projection, constantly unfolding from this deeper implicate order, what does that really mean for how we understand ourselves? For our understanding of reality itself? And what is the true nature and role of information in the cosmos? Could it be that the separation we perceive between ourselves, between objects across time, is the deepest level of illusion, and that everything is fundamentally interconnected in ways we're only just starting to imagine? That's definitely something profound to think about.